Good morning, students. Today I will explain you combination of the resistors. See, if you are given 3 or more resistance, you want more resistance or the less resistance, then we have to join the resistance in this form that you get the desired resistance. Now combination of resistance, it may be in series, it may be in parallel, or it may be in both series and parallel. See, in the case of the series, resistance they are arranged head to tail, and there will be addition of the resistance, so you will get the more resistance in the case of the series. So first I will take in series, suppose 3 resistance R1, R2, R3, they are arranged in series, that is head to tail. So circuit is formed, R1, R2, R3 in series, and it is attached to the source. Now in series, equivalent resistance will be R1 plus R2 plus R3, and we know that in this series potential difference changes, so the total potential difference between the across of the two ends is equal to V1, V2 and the V3, and you know V is equal to IR, so the total current and the resistance V is equal to IR, then IR is equal to IR1 plus IR2 plus IR3, and no current is constant, then equivalent resistance of the 3 resistance is equal to R1 plus R2 plus R3. So in series, when the resistance they are arranged head to tail, the total resistance is the addition of all the resistance, because here potential difference changes and the current remain constant. Now in second case, in parallel, you see R1, R2 and the R3, 3 resistors, they are arranged in parallel and connected in a circuit. Now in the case of the parallel, potential difference does not change while the current changes. So if input current I, it is divided into 3 resistance I1, I2, I3, then the total current is I is equal to I1 plus I2 plus I3, and we know I is equal to V upon R, so the total current, that is V upon R, I1 is V upon R1 plus V upon R2 plus V upon R3. Now here, if we take V as a common, then the 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. In this case, the total resistance is the reciprocal, so the total resistance will be less than the individual one. Listen, in the case of the parallel, the total resistance will be less than the individual one. So if 1 upon R, we take 2 resistance is equal to 1 upon R1 plus 1 upon R2. If we simplify by taking LCM, then the resultant R is equal to R1 into R2 upon R2 plus R1. So in series, you are getting the total resistance is addition of all the resistance. While in the case of the parallel, you are getting resultant resistance as the less than the individual one. Now suppose if you have 3 or more resistance and you want to a desired resistance, then if we arrange in series and parallel both, suppose 3 resistors are 2 ohms each, 3 resistors are 2 ohm each, out of 3, 2 are taken parallel and third is in the series. In such cases, always first solve the parallel resistance, then this parallel resistance will be in series to the third one. It means the total resistance will be the R of the parallel plus the series. So here first we will calculate the total resistance of the parallel, that is 1 upon R is equal to 1 upon 2 plus 1 upon 2, taking LCM it is 2 upon 2, then the resistance is equal to 1. Now you know in the parallel case we get resultant resistance is less than the individual one, so here 1 is less than the 2. Now this 1 and in series is 2, then total resistance of this combination will be 3 ohms. So this is how we arrange for the desired resistance in series and the parallel. So 3 types of the combinations are there: in series, in parallel, and in both series and the parallel. Listen, in series, potential difference changes while the current remains constant. And then total resistance is equal to sum of all the resistance, that is R1 plus R2 plus R3. But in the case of the parallel, potential difference remains constant and the current changes. Then total current is equal to I1 plus I2 plus I3, and I is going to be upon R. Then putting the value, we get resultant resistance, that is 1 upon R is equal to 1 upon R1 plus 1 upon R2. And if it is in combination of the series and the parallel, listen, always first calculate the resistance in the parallel, then add to the series. Okay, so I think it will be clear to you combination of the resistance. If you like my videos, please share and subscribe. Thanks very much.